And today our topic is about statistical analysis on birthday popularity in October 2022. So our team members, we have Siti Amira, Nur Amira Ilyana, Sohki Siang, Amar Zikri, and Tuan Nurul Adira. So first, let me start with the introduction first. Statistics are important in helping people understand information and identify patterns from data. This study focuses on birthday popularity by analyzing the number of birth registrations in Malaysia from 1 October 2022 until 31 October 2022. The data used in this report was obtained from the Malaysian government's official website, which is data.government.my. The objective of this study is to analyze the distribution of birthdays using statistical methods such as frequency tables, measures of central tendency, measures of dispersion, and graphical presentations. Here is the data collected for birthday popularity in October 2022.
Next, I'll be explaining about frequency table. This section presents the frequency table for the total number of births per day. The data has been grouped into 5 classes. The first class, ranging from 97,000 to 100,799 births, contain 18 days. The second class, ranging from 100,800 to 104,599 births, contain 9 days. The third class, ranging from 104,600 to 108,399 births, contain 2 days. The fourth class, ranging from 108,400 to 112,199 births, contain 1 day. The fifth class, ranging from 112,200 to 115,999 births, contain 1 day. Overall, the data is consists of 31 observations. Step 1. Arrangement of data in ascending order. This is the way how to do the frequency table. So the first step is to arrange all observations in ascending order, starting from the smallest value and ending with the largest value. The smallest value of birth recorded is 97,491, while the largest number of birth recorded is 115,573. Arranging the data in ascending order helps us identify the data range and make it easier to construct the frequency table. Step 2. Determine the numbers of classes. The second step is to determine the number of classes. The total numbers of observation is 31. Using the formula for determining the numbers of classes, the calculated value is approximately 4.954. After running to the nearest whole number, the number of classes becomes 5. Therefore, 5 classes are used in this frequency distribution. Step 3 is to calculate the class size. The lower boundary is 97,000, while the upper boundary is 115,999. The difference between this value is divided by the numbers of classes, which is 5. The calculation gives a class size of approximately 3,799.8. The value is rounded to 3,800. Therefore, each class interval has a width of 3,800. The fourth step is to construct the class intervals using the class size of 3,800. The first class interval starts with 97,000 and ends at 100,799. The second class interval starts at 100,800 and ends at 104,599. The third class interval starts at 104,600 and ends at 108,399. The fourth class interval starts at 108,400 and ends at 112,199. The fifth class interval starts at 112,200 and ends at 150,999. These intervals cover the entire data set without overlapping. The final step is to count number of observations that fall within each class interval. For the first class interval, from 97,000 to 100,799 births, there are 18 observations. For the second class interval, from 100,800 to 104,599 births, there are 9 observations. For the third class interval, from 104,600 to 108,399 births, there are 2 observations. For the fourth class interval, from 108,400 to 112,199 births, is 1 observation. For the fifth class interval, from 112,200 to 115,999 births, there are only 1 observation. In conclusion, 31 observations of daily birth total were analyzed and grouped into 5 class intervals. The highest frequency occurs in the first class interval, which is contain 18 observations. This shows that the most daily birth total fall between 97,000 and 100,799 births. As the number of births increases, the frequency decreases, indicating that higher birth total occurred less frequently during the period studied. Thank you, and I will pass to my friend to continue.
For the part 4, central tendency and dispersion, here is the group data table used to calculate the measure of central tendency and measure of dispersion. The table contains the class interval, which is the number of births, and class boundaries, frequency, cumulative frequency, midpoint, fx, and fx squared. The class boundary are calculated by subtracting 0.5 from the lower class limit and adding 0.5 to the upper class limit. The frequency column shows the number of observations in each class, while the cumulative frequency is obtained by successively adding the frequency from the first class to the last class. The midpoint of each class is calculated using the formula lower class boundaries plus upper class boundary divided by 2. The fx value are obtained by multiplying the frequency by the midpoint. The fx squared value are obtained by multiplying the frequency by the square of the midpoint. Finally, we calculate the total frequency by adding all the frequency value, which given 31. We also obtain sum of fx and sum of fx squared by summing all the value in the column respectively. For 4.1, measure of central tendency. Measure of central tendency are statistical value that represent the central point or typical value of a data set. These measures provide a summary value that characterizes the distribution of data, which make it easier to understand and interpret large data sets like the total number of births in October 2022. There are three main types of average commonly used as measure of central tendency, which are the mean, median, and mode. For 4.1.1, the mean. The mean is calculated by summing all the value in the dataset and divide them by the number of value. It represents the average value of the dataset. For the total number of births in October 2022, the mean provides an overall average number of births per day throughout the month. The formula of the mean is the sum of product of frequency and midpoint divided by the total number of data. After calculate, we found that the sum of product of frequency and midpoint is equal to 3,141,884.5. The total number of data is 31. Then we substitute into the formula. We get mean is approximately equal to 101,351 births per day. For the 4.1.2, the median. The median is the value that lies in the center of data. The medians indicate the central point of the dataset and is useful for understanding distribution of birth number, particularly in skewed data. The formula is as follows. After calculating, we found that the lower class boundary of class median is 96,999.5. The number of classes is 31. The position of median classes is 15.5. The cumulative frequency before the median class is equals to 0. The frequency of the median class is equals to 18. The median class size is equals to 3,800. After we substitute into the formula, we found that the median is equals to 100,271.72. For 4.1.3, the mode. The mode is the value that appears most frequently in the dataset. The mode identifies the most common number of births on any given days in October 2022. The formula is as follows. After we get the model class and calculating, we found that the lower boundaries of the model class is equal to 96,999.5. The first frequency difference is equal to 18. The second frequency difference is equal to 9. The model class size is equal to 3,800. After we substitute the value into the formula, we get the mode is equal to 99,532.83. For 4.2, measures of dispersion. The dispersion of data is known as dispersion, variation, or variability. The measure of dispersion is important because two groups of data may have the same central value, but they have different variability. It can be measured using range, interquartile range, quartile division, variance, and standard deviation. For 4.2.1, range. Range is the simplest measure of dispersion. It measures the total spread of the data. Range is the difference between the highest and lowest value in a set of data. The highest value here is equal to 115,999.5. The lowest value is equal to 96,999.5. Then we substitute this into the formula to find that the range is equal to 19,000. For 4.2.2, the interquartile range. Interquartile range is the difference between third quartile and first quartile value in the dataset. First, we need to find the location of first quartile, which is equal to 1 multiplied with the total number of data, which is 31, and divide by 4. Then we will find that the location of first quartile is at 7.75 place. Then we need to find the first quartile value using the formula. After calculating, we found that lower boundary of the first quartile is 96,999.5, and the location of the first quartile is 7.75. Cumulative frequency before the first quartile is equal to 0. Frequency of the first quartile is equal to 18. The class size is equal to 3,800. After substitute the formula, we find that the first quartile value is equals to 98,635.61. Next, we need to find the location of the third quartile, which is equals to 3 multiplied with n, which is the total number of data, 31 divided by 4. And then we will find that the location of third quartile is equals to 23.25 place. Then we need to find the third quartile value using the formula as follows. After we calculate, we found that the lower boundaries of the third quartile is equals to 1799.5. The location of third quartile is 23.25. The cumulative frequency before the third quartile is 18. The frequency of the third quartile is equals to 9. The class size is 3800. After we substitute into the formula, we find that the third quartile values is equals to 103,016.17. Then we can find the interquartile range IQR by subtracting the third quartile with the first quartile. Then we will find that the IQR is equal to 4,380.56. For the 4.2.3, the quartile deviation. The quartile deviation is not affected by extreme value, but is based on only 50% of the distribution, and the remaining 50% are ignored. To calculate the quartile deviation, we use the formula third quartile minus with the first quartile divided by 2. And the result of third quartile minus with first quartile is equals to 4,380.56. After that, we divide by 2, we get that the QD is equal to 2,190.28. For 4.2.4, variance. Variance determines how the data value fluctuated around the mean. The variance is the mean value of the squares of the deviation from the mean, written as sigma squared. First, we need to find the mean or the average population by using the product of frequency and midpoint divide to the total of frequency. Then we will get that the mean is equals to 101,351.11. Then we can use the formula of variance. After substitute all the info like product of the frequency and the square of the midpoint, total of frequency, and average population, we will find that the variance is equals to 30,554,053.63. Remember that the mean, we need to put the square. For the 4.2.5 standard deviation, the standard deviation is commonly used as a measure to compare the spread in two or more sets of observations. A large value of standard deviation for a given data indicates that the value of the data are widely dispersed from the mean. Conversely, for a small value of standard deviation, the values are spread close to the mean. This is clearly stated by Chebyshev theory and the empirical rules. To find the standard deviation, we need to square root the variance. After we square the variance, we will find that the standard deviation is equal to 3,681.58.
Now, I'm going to talk about the interpretation of the measures of central tendency. To make interpretations easier, the data must first be organized into graphs. In this video, we will be using a histogram, frequency polygon, and Ogive graph. A histogram is a graphical representation used in statistics in order to show the distribution of numerical data. In this case, the histogram shows the number of days or frequency that has recorded a certain range of births. For example, from the graphs, we can see that 18 days have had between 96,999.5 and 100,799.5 births. The red line represents the frequency polygon. A frequency polygon connects the midpoints of each class interval and helps to highlight trends and patterns in the data more clearly. Finally, the Ogive graph uses cumulative frequency plotted against the upper class boundaries of each interval. As shown on the graph, the cumulative frequency reaches 31, which represents the total number of days in the dataset. This graph is useful for identifying the median, quartiles, and other cumulative measures.
Conclusion. The report on the number of babies in October 2022 has been successfully produced, and an overview of the statistics about babies in the selected period of time is presented. This report can be useful in understanding population growth trends and demographic change in society. This assignment proved the significance of proper collection, organization, and interpretation of data. Several skills were also improved throughout the assignment, such as critical thinking skill, problem-solving skill, communication skill, analysis skill, teamwork skill, time management skill, and research skill. All the objectives have been met in this report, and the study helped in realize the importance of statistics in day-to-day life and in the development of a nation.